All right, today we're going to talk about stoichiometry. That's all the chemistry math. You've already been doing a lot of it with the triangles. You've been doing 2/3 of the stoichiometry already. So you have your steps to doing it correctly. Obviously, you have to write the formulas correctly, balance the equation, identify what you're given, and determine what you are looking for, and then take out a calculator and solve. So we're going to do a practice problem together before you do all the practice problems in the class. So sodium hydroxide reacts with phosphoric acid to produce sodium phosphate and water. If you have 30.45 grams, remember that's important, you want to know how many grams of water. So step 1 is to write the equation.
Alright, so there's our equation with all the formulas written correctly. Then our step 2, balance those equations, make sure we have the same amount on each side. Then we need to read the question and identify what are they giving us and what do they want us to know. So they're giving us that we have 30.45 grams of sodium hydroxide, and they want to know how many grams of water. Alright, so then our next step is we want to solve the equation. Alright, so don't freak out when you see this. You've already done the front part and the back part. So you always write down what they gave you first. So they gave us 30.45 grams of sodium hydroxide. And then you can either write it like this, or it's the same thing as your triangle. I'm going to write 1 mole of sodium hydroxide on top and 40 grams of sodium hydroxide, which is the molar mass.
Okay.
And then in the second step, we're going to look at our balanced equations. We have, if we look at the number in front, so there's 3 moles of sodium hydroxide, and there are 3 moles of water. So I'm going to put 3 moles of sodium hydroxide on the bottom, so that those units will cancel out, and 3 moles of water on top. Now, I don't want moles of water, I want grams of water, so I got to do one more step. And I'm going to use the molar mass of water, so I'm going to put 1 mole of water on the bottom, so those units cancel out. And 18.02 grams of water is the molar mass. And then I plug and chug all that into my calculator, multiply the stuff on the top, you divide the stuff on the bottom, you get 13.72 grams water.
Now if you're uncomfortable doing it written out all the way like this, then go from grams to moles of sodium hydroxide, and then moles of sodium hydroxide to moles of water, and then from moles to grams, just like you've been doing all along. We don't care how you get to the correct answer, just that you're getting to the correct answer. So the next thing we're going to talk about is percent yield. How much do we actually get? How much is produced? So you put the actual, what you get in the lab area, that's from the lab, over what you expect, the math stuff, what we just did. So that's the math. Why does it matter? Well, if you're in industry and you're making a product and you're only getting 50% of your expected product out, you're losing a lot of money. So you want to make sure that you can figure out why you're losing it and where to fix it from. So of course we have a practice problem as always. If you've got 10 grams of water produced, what is the percent yield? So that's going back to the previous problem. If we actually end up with 10 grams instead of what we calculated.
Alright, so we only produced 10 grams of water, but from the previous question we should have produced 13.72 grams. So I'm going to divide the actual by the expected, multiply times 100 to make it a percentage, and I'm getting about 72.89% of what I should have been getting.
Which is not a very good yield if you're producing water for sale and everything else. You're losing a lot of money there. Alright, that is stoichiometry and percent yield. We'll see you in class for all the wonderful practice that y'all love so much.